that is the easiest one because it's when we have polar molecules. So like if you have HF. So I know that fluorine is more electronegative than hydrogen. So we attract the electrons more to its area, forming a more like a dipole over here. So partial negative charge over here, and here I have a positive charge and the hydrogen. So what happened, we'll find another molecule over here and will bond with this other molecule. And this molecule will find the fluorine over here, will bond with this, forming like intermolecular force over here, dipole dipole, because they are already formed, they existed, okay, like we have between water. So water is a polar molecule, so they will attract the electrons for more. The oxygen will pull the electrons to its area, forming a negative, partial negative charge over here and the partial positive charge over there. So that will make the other water molecule connect with. So this is what make this dipole force stronger than the other, because the dipoles already exist. Okay, so that is attractive force between polar molecules. So here it's important to remember what is electronegativity means. So you need to understand electronegativity. And also a little bit of geometry will help you a lot. So I know that we're gonna talk more about the geometry and lab, but I can teach you some tricks. Like for example, if I have imagine a carbon, okay, connect to hydrogen, so that is we have 4 bonds, and we have 4 atoms connected. They are equal. So we have a non-polar. But we need to know like some vectors, like here, fluorine and fluorine and fluorine. They are equal, 3 bonds, right? And 3 atoms. We don't have any non-pair electrons around the boron over here. So, but you need to know the force, the resulting vectors over here. So we have parallelogram. So the resulting is over here. This will cancel the other vectors. So the dipole moment will be 0. So it's non-polar. But if you have just one element here different from the others, that will be polar. So that is a trick that I use it to know which one is polar, which one is non-polar. And when you have only 2 elements, they are different, so we have a polar molecule. And hydrocarbon is always non-polar. But you're gonna study a little bit more about this polarity and the other chapter, mainly when you talk about geometry. So, and some dipole, it's so strong that they deserve a different name. So that we call hydrogen bonds that will occur in molecules that we have hydrogen bond with fluorine, oxygen, and nitrogen. Why this happen? Because fluorine, oxygen, and nitrogen are the most electronegativity elements in the periodic table. So they form a very strong bonds. So like here in the water molecules, and they always use dots like this to represent all little lines like that. So we have a lot of hydrogen bonds in our DNA, for example, and you need to pay attention that only happen in molecules that we have a hydrogen connected to fluorine, oxygen, or nitrogen. And that will, this type of force, or actually the intermolecular force in general, will affect a series of important properties like boiling point, vapor pressure, or solubility, a lot of different properties. For example, if you have iron in a solution and the iron has a stronger bond with the solution, then will be miscible easily, right? Become completely miscible. So, so if you have a significant increase in boiling point, for example, if you have a hydrogen bonds, this is why water is 100 Celsius degree, okay? Let's see if you understand a little bit what is making the difference between dipole, dispersion, or hydrogen bonds over here. So we have here two examples. So here we have asking the type of intermolecular forces existing in the following pairs. So that means the interaction between those two. I have here, remember, two different atoms. We have a polar over here and here also polar. So if they are polar, we're going to have a dipole, right? And also I have over here this chlorine. So they are two same elements. So they are non-polar. And here I have a carbon that make 4 bonds. So I have bromine and bromine and bromine. They are equal, remember? So non-polar, 4 bonds, 4 equal atoms, so non-polar. So the interaction, the intermolecular force between two non-polars will be London or dispersion force. So dispersion force exists in every single molecule. So that means here we have dipole, but also we have a dispersion force. Okay, always have dispersion force because the electrons are always in movement. So, and here indicate which of the substance has the highest boiling point. Boiling point. So here we have ammonia. So remember, hydrogen bonds happen when you have hydrogen connect to fluorine, oxygen, or nitrogen, right? And I have here nitrogen connect to hydrogen, so I have a hydrogen bond, which is stronger than any other, but we can keep going over here. So here I have a CO2. CO2 is this, and this is a non-polar molecule. Non-polar molecule is dispersion force or London force, right? And I have this one that is polar. So I have what I have over here, dipole. So the highest boiling point over here will be over here. Oh, sorry, should be this pen. Okay. So that's the highest boiling point over here. Okay, because that's the strongest